Dear learners, I welcome you back to another session of Research Methodology course for Tourism and Hospitality Management. We have been going through a very important topic in the last module, and you are aware that statistical techniques and tools are used time to time by researchers. Getting a good result from your data analysis depends upon how you collect the data and how you make the scheme for analysis and what output these results produce. So in the beginning, we studied about non-parametric tests. I hope you remember we dealt with categorical variables in general. Once again, to update you, we have two types of variables that we use for analysis. One is categorical variable and the second one is continuous variable. In categorical variables, we just take the numbers in order form. That is gender as an easy example, male, female or others. Then we have levels like yes, no, maybe. So in many questionnaires, we find dichotomous questions and also the variables which measure the order of a particular event or a particular output. So in today's session, we will be dealing with parametric tests. Parametric tests are considered to be more stringent in following assumptions and also very precise in producing the outputs. So let us see the topics that we are going to cover in today's module. So dear students, we have a number of tests which are related to measuring continuous variables. We have interval and ratio variables. Hope you might be remembering. There are several measurements which are including decimals, which also include discrete numbers. So in the beginning, we will be dealing with a particular test called a t-test. Another interesting factor is the sample size may vary time to time. At times you may have a very small set of samples, but at times you may have large set of samples. So when you have sample size small, that will impact the result. And your variables are measured in metric way. So it's called metric variables. An alternative for this is to use t-test, also known as student t-test. So let us see in detail t-test in the beginning. And in the latter part, we will go through a test called analysis of variance. So I told you t-test is dealing with normally small sample size. So, and it deals with exclusively metric variables. So when we collect the data, we should be careful, go with the probability sampling in such case. And there are three different levels of measurement here. One is a single variable on which we have to measure certain output. And second, we have two independent variables known as independent sample t-test. And the third one is we have measurements at a different point of time. Time 1, time 2, or before or after, pre, post. So such kind of measurements that we normally do through performing t-test. Let us take an example here. I am going to give you a background once again. We have a population and we have a sample too. The population representing the whole set of respondents. From this population, we choose a particular sample. The sample size is normally small in comparison to the population. So what we have to check is the sample that we draw having the similar characteristics or the features of the population. So that is why we are doing this test. So in almost all tests, our purpose is whether our sample is representative to the population. Once again I repeat, what we have to identify, the sample is representative. So we have to frame hypothesis, and when we perform the test, the hypothesis testing will tell you whether the sample is representative. So the first case we are going to deal today is an example from my own experience. I have students pursuing graduates, postgraduate students, and they give examinations. So I draw a sample of 20 students and I have taken their CGPA score. So the metric variable here is the CGPA score of 20 students. My past experience says the mean score of CGPA of students fall around 7, or it can be 7.5. I'm just hypothetically saying. So the hypothesis is set here. The mean score of CGPA is 7. And you can find the alternative hypothesis in the next line. Here we are taking the level of significance, that is 0.05. That is, we are 95% confident that the sample mean is falling around 7. Now look at the table. You can find the title. It is one sample t-test. I used SPSS software to calculate the mean value. Once again, don't worry about the numbers, just see the titles and try to understand. Here you can find what I am going to measure, CGPA. So here there are certain terms that you keep in your mind. That number one is t value. The second one is DF. Here it means degree of freedom. Normally it is 1 minus the total population, here in case of t-test. Then you can find significant, two-tailed significance values, then the mean difference, then upper level or lower level of the score. How we will see the result here? First, you have to check t value. That means the calculated t value of this test is 34.820 with a degree of freedom of 19, and the p value is less than 0.05. That is the answer. So how do you interpret this result? The probability that a sample with mean difference 7.31 or more will be drawn from the population is 0%. That is, it is statistically significant. So the significance level is set at 5%, and which is higher than 0%. So there is a significant difference exists between the sample and the population assumed. Now let us see the outcome of the statistical test that we performed. What is the name of the test? One sample t-test. What we are measuring? We are measuring the CGPA score, whether the mean is 7. You will find the first one CGPA. Next you can see t value, then DF. T value is the calculated t value. DF means degree of freedom. In 19 cases, how this result is going to apply. Then the significance level. This is a two-tailed test that we used, and the result is 0.000. The mean difference. Here the mean of the whole the distribution, that means 20 students score is 7.31. So this is almost close. And now you can find also another result here, test value. Once the test value changes, the score also will change. So we want to know whether the score of the students is remain same or different. If it is same, the significance It should be more than 0.5. So when you write the answer, you can find here is null hypothesis rejected. Why? We have given the reason, the calculated t-score, then we have degree of freedom, and the p value, the probability value is less than 0.05. Now, I have given the explanation below because the score 0.00, it is less than 0.05. Hence, the probability that a sample with a mean difference of 7.31 or more will be drawn from the population is 0%. So, this 0% is greater than the significance level that we get, that is 5%. So, this reason the significant difference between the sample and the population is assumed. So, let us see another example. Here you will find the same, I have changed slightly the value, that is called CGPA 1. Now the t value drastically came down, and the DF is same. Look at the significance value. It is 0.153, that is 15%. Earlier we kept it at 5% and our score was 0.000. Now what is the change you see here? The test value. Test value is 7. So this particular t-test shows the null hypothesis retained. There is no significant difference because the calculated value which is falls close to 7. Look at the SPSS sheet which is available in your screen. You can find the value titled CGPA 1. Carefully see how I am going to do the statistical test, so that when you work yourself, it would be helpful for you to understand. I am choosing compare means. Under compare means, you can take one sample t-test. So I am taking the CGPA score here 1. So you will get an outcome instantly. It shows this one sample t-test. The number of observations are 20. The mean value is 7.31. And the t-score which we checked earlier is given as it is. So when you change the value here, let me again do another analysis. Compare means, go to one sample t-test. Instead of test value 0, let us put the test value 7. See, the significance became, the value changes. When I change the test value, you can find the score also changes here. So let me show you the last example with this. I am choosing another variable that is meant for this demonstration. Here there were 30 samples and I got a mean score of 5.86. The present value that stands with a mean value of 5.86. The test is again a statistically significant result we can get from this particular score. Just imagine that I am changing some values here, the data, so that the data looks more similar, homogeneous. Now most of the values are very close to 7. Let us do another experiment. Compare means one sample, yes, the mean value has changed. Now it remains the statistically significant result. The population mean differs from the sample mean. So like this you can do experiments at your end. I'm just showing you an example. So when you do repeated experiments, it will be easy for you to understand one sample t-test. Let us come back to the next level of experiment, that is independent sample t-test. We have two different samples drawn from the same population. Whether the outcome of the analysis is same for both, this is what we analyze through independent sample t-test. It is widely used in tourism and hospitality research. Let us see the example given here. So I have taken two different samples, that is boys and girls, and the population is same. So what I am going to check, the CGPA score of the boys and girls are same or not. Now when I did the analysis, I got this result. So you can find the boys scored close to 7.93, the mean score. The number of boys 10, number of girls again 10. The mean value is close to 8. There is no much difference. We have to know whether it is statistically significant or not. So first you have to check the F value, Levin's test, because this is testing an equality of variance. Here you can find the Levin's test is not significant. So now let us also see the t value. This is not statistically significant. Means the null hypothesis says that both there is no significant difference in the score of boys and girls. So in this case, the hypothesis is retained. Let me show you another example. See this example. Here the boys have a mean score of 6.18. So what is the mean score of girls? 8.20. Visibly there is a difference in the mean value. So how this statistically reflect? When you do the test, you can find that the Levin score is not significant. So that assumes the equality of variance. Then it becomes t value becomes significant. So now you tell me whether the score of boys and girls are same or not. That means we come to a conclusion of null hypothesis is rejected. So this particular table is a real example to check the performance of two groups. You can use independent sample t-test for your research. With this we will proceed to the next type of t-test. This is called paired sample t-test. Paired sample t-test, here we are measuring the performance before and after or pre and post. So two different time. Imagine that we are using a particular assessment experiment. Let us take an experiment, and in the before experiment, how was the performance? After the experiment, how the candidate is performing? So we can analyze it through paired t-test. The hypothesis is the difference in earning. Okay, let me tell you what is the problem, research question. The question for this particular case, imagine that you completed your intermediate or you are pursuing your graduation. Ministry of Tourism conduct tourist facilitator training and you have become part of that. Imagine you got a certification and you get involved with helping the tourist. So let us see, without having training and after training, what changes we have. So this reflects statistically too. Let us see the outcome after doing the test. So I have two data set with me. The first one is, you can see before training. Imagine that this individual was earning 981 rupees without training or before training. After an year, after getting certificate and after an year of experience, it increases. So this is the mean value. This is taken from a sample of 20 respondents. So now let us see the result of the paired sample t-test. So here first we can check whether there is a correlation or not. Here you can find a correlation of 0.762 with a significant. So statistically significant correlation before and after training. Means before training it was low, after training it is increased. Now the outcome of paired sample t-test is, see, look at the t-value first, 21.415, and two-tailed test, which is p is equal to 0.000. So this t-test reflect a statistically significant relation, that is before and after. That means there is a difference in earning. The null hypothesis is rejected here. Dear students, we have taken up 3 different examples, 3 different tests. So what I repeatedly used in this module so far, one is the sample mean and hypothesis, the p-value, rejecting null hypothesis or retaining null hypothesis. So when you do practically these experiments, when you have a good data set, it would be easy for you to understand and explain when you do work on research. It will be helpful for you to when you do your research. We are going to discuss another parametric test called ANOVA. In the beginning, we are going to discuss one-way ANOVA, that is analysis of variance. Here we need a metric variable and we need categorical variable with 3 or more levels. As I said, it could be yes, it could be no, or maybe responses, maybe. So 3 possible responses we can find. The example I have taken here is the training an individual undergoes. Here you can find the example, a candidate who did UG, or a candidate just completed graduation, or an individual with a basic education, primary. What changes in their earnings we have? In a particular situation, an individual with the primary level earned 936 rupees. And second, the person with the high school 865 rupees. And see, a person with a graduation scores 1135 rupees. Here what we are going to test? We are going to test a statistically significant difference between 3 group of candidates. Candidates with UG certification, high school certification, or primary level certification. So first thing is we have to check the homogeneity of variance, and in the last test also we used Levin's test. So this statistic shows significance. That means there is an equality of variance. Now when you do the analysis, we can find the F score, that test result is checked. The statistic of ANOVA here is F. Remember, we have seen Z value, we have seen T value, and now we are using F value. F value is statistically significant. It is less than 0.05. We have some more tests to confirm, which group is having the variation. Because this ANOVA table, it only tells you whether there is a difference exists between the 3 groups. To do that, we have to use a test called post hoc. Post hoc test, I have used Tucky HSD. This is possible through the softwares. We have to check whether an asterisk is present in these tables, mean difference tables. See, where are the asterisk present? Number 1, when we compare UG with high school and primary, with high school, there is a mean difference of 270. It's natural that there is a change in earning. So we can find that major difference that we find is UG with high school. I hope you are clear. So the finding of this study is there is a statistically significant difference exists in 3 groups. But the post hoc test which says that the difference is visible, that is between UG and high school. Dear learners, today we have seen the application of t-test in varying context. Remember, we started with one sample t-test, then we have seen independent sample t-test, third paired t-test. So I hope these examples will help you to come to a conclusion and it will ease your study process. In the last, we have taken an example of one-way ANOVA and we have seen how we have to interpret the findings. The ANOVA result is checked through the F value and corresponding probability score. And if there is a significant difference, you have to go ahead with post hoc test so that your findings will be supported by statistical evidence. So it is very interesting to work with the real data. I hope you had a good learning session today. If you have any doubts, please come back to me. Thank you.